Hi all, our first topic is Introduction to Green Chemistry, and today we are going to discuss what is green chemistry, the need of green chemistry, and the goals of green chemistry. What is green chemistry? We all know that chemistry is undeniably a very prominent part of our daily lives. It has brought about medical revolution, for example, synthesis of drugs, etc. World's food supply has increased due to discovery of hybrid varieties, improved method of farming, better seeds, and use of agrochemicals like fertilizers, insecticides, etc. But chemical developments also bring new environmental problems and harmful unexpected side effects, which results in the need for green chemical products and processes. We as chemists should recognize our responsibility to work towards a new phase of chemistry which will sustain and improve the quality of life for future generations. Green chemistry is a comprehensive program based on non-regulatory and economically driven approach to achieve the goals of environmental protection and sustainable development. Green chemistry was invented by Paul Anstas in 1991 and it's a way of using basic science to address environmental issues in an economically profitable manner. Green chemistry is defined as environmentally benign chemical synthesis. It focuses on a process, whether carried out in industry or chemical laboratory, that reduces the use and generation of hazardous substances or byproducts. Green chemistry is all about waste management, use of non-toxic reagents, use of renewable resources, improved atom efficiency, use of solvent-free or recyclable environmentally benign solvent systems. The need for green chemistry. Chemistry has played a vital role in improving our lives, but all these developments are responsible for various environmental problems. And some of those environmental problems are: first one is due to pesticides. Although their use has helped to increase food production and control certain insect-borne diseases, they also pose health risks to human and environment. For example, DDT, which is an insecticide, and the, the widespread use of DDT has resulted in pollution of croplands, and a large number of pests have become resistant to it. When it enters the food chain, DDT accumulates in the fatty tissues of animals. As a measure of green chemistry, stress is now being laid on biological control of pests using harmless substances and not harmful chemical substances like DDT. Second one is chlorofluorocarbons. These are extensively used as a refrigerant in air conditioners, etc. CFCs react with ozone in the upper atmosphere under the influence of UV radiation. Large concentration of CFCs in the stratosphere over the polar regions have led to the destruction of ozone layer and form ozone hole. Attempts have been made to discover other refrigerants which are biodegradable as a substance for CFCs. And third one is acid rain. It is caused by the discharge of pollutants like oxides of nitrogen and sulfur by various industrial processes and power plants. Acid rain, as we know, washes away the nutrients in the soil, affects plants and monuments made of marble. In view of the adverse effects, attempts are being made to use alternative sources of energy. Global warming. The release of greenhouse gases like CO2, methane, nitrous oxide, and CFCs into the atmosphere has far-reaching effects on the climate due to increase in average temperature of Earth's atmosphere. This would in turn alter the ecological balance. Fifth one is Bhopal disaster. A most tragic chemical accident in the history of mankind in a pesticide manufacturing factory occurred in Bhopal in the night of 2nd December 1984. It led to the death of about 25,000 people and injuries to more than 2 lakh people. In this accident, approximately 33 tons of methyl isocyanate, an extremely poisonous gas, escaped from a storage tank and spread over the city of Bhopal. The cause of accident was due to failure of various controls and was attributed to human error. The next man-made disaster is Minamata disease. Minamata disease is a neurological syndrome caused by severe mercury poisoning affecting the nervous system. An outbreak of Minamata disease was first reported in May 1956 in Minamata Bay, Japan. Mercury poison entered the food chain, contaminating the water, then the fish, entering the human and land animals. These are several examples of environmental hazards due to some harmful chemicals. Therefore, it is in this context that green chemistry plays a vital role in keeping the environment clean. The concept of green chemistry addresses environmental issues in an economically profitable manner. Green chemistry makes it more or less mandatory for the industries to see that appropriate starting materials and conditions be used so that there are no hazardous byproduct generation. The goals of green chemistry. Green chemistry aims to eliminate or estimate or at least reduce the pollution by preventing it from happening as far as possible. The goals of green chemistry is to design synthetic methodologies that reduce or eliminate the use or generation of toxic products. For that, all possible routes for a particular synthesis must be examined, and the most appropriate route, which uses non-hazardous starting materials, should be used. Care should be taken to see that non-hazardous byproducts are formed. This could be well understood by considering the manufacture of adipic acid. About 2 billion kilograms of adipic acid are required each year for making nylon, polyurethane, lubricants, etc. The usual starting procedure of making adipic acid uses benzene as a starting material, which causes cancer. In a newly developed process that is aided by biocatalysis, genetically altered bacteria, the simple sugar glucose can be used as the starting material. Thus, the use of large quantities of harmful chemicals can be avoided. Thus, green chemistry incorporates pollution prevention practices in the manufacture of chemicals and promotes pollution prevention. That's all. Thank you.